Okay guys, today we are doing inverse functions. So we are going to solve the equations, solve for the inverse, but let's talk about what inverse function, because we want a function, what that really means. So in the past we have said that to be a function, there is every x has one y, okay? So we know this by doing the vertical line test, and that is a function, right? Well, the horizontal line test will actually tell us if the inverse is a function or not, okay? So think of our parabola down here. So our parabola is a function because if we do the vertical line test, it works. But if you see here, if we do a horizontal line test, it cuts through it twice. So the function itself of x squared, the inverse is not a function unless we restrict the domain. So as you can see in the graph, what happened here is I restricted the domain from 0 to infinity, because now if I only take half the function, it passes the horizontal line test. So let me go back up to some vocab. The inverse of a function, of course, switches our x and y. So it takes our output and our input and switches them. And to be a one-to-one, the original function and the inverse are both functions, okay? That's one-to-one. So if we do the regular function x squared, it would not be one-to-one unless we restrict the domain, because now after restricting it, our inverse is a function, okay? So that is right down below. Okay, so now that we described what an inverse is, we're going to look at some graphs and do some algebra here. So what we can do is this. If I know the inverse function is just switching x and y, I can see that we have a coordinate pair right here of -1, -2. This coordinate pair is 1, 1. And this coordinate pair is 2, 5. So on my inverse, I'm going to switch these. I'm going to make it 5, 2. 1, 1, and -2, -1, and I'm going to graph these now. So 5, 2, 1, 1, and -2, -1. So the inverse will fall like this. Okay. Ta-da! Now, if we're going to do most of this by algebra, so let me explain this example. What we want to do here is take the function f of x, and we are going to switch x and y. Okay, f of x is y, guys. Okay. So we switch x and y, and then we are going to solve. Switch x and y, and then we are going to solve for y. So if we want to get y by itself, we would then subtract 7 from both sides, divide by 5, and we get our inverse. Now what I really want you to pay attention is it's not really y, because you can't say the y's equal two different things when they're not. These do not equal. So what we're going to do is rewrite this in inverse notation. So when you write inverse of f of x, you stick this -1 in like an exponent. So this is the inverse of f of x. So let's try one together. Remember, we're going to start by this is y, but we're going to switch x and y. So I get x equals 1/3 y minus 8. We are going to get y by itself, so the first thing I'm going to do now is add 8. Don't do too many steps at once, because that's where we confuse ourselves. So right here I get x plus 8 equals 1/3 y. Now, how do we get y by itself? How do we get rid of the 1/3? We multiply both sides by 3. So I'm going to write this out with parentheses because you have to multiply the whole side. Okay? So our inverse, and I can distribute that if I want. So I get 3x plus 24. Now I'm going to write the inverse of our function. So I write f to the -1 of x. And that's our answer. Okay, we're going to do some more complicated ones. Okay, again, this is our y. Switch our x and our y. So we get x equals the square root of 2y minus 3 plus 5. Okay, remember order of operations. So we're going to subtract 5 first. I get x minus 5 equals the square root of 2y minus 3. Right now, what we have to do is we have to get rid of the square root first, because that is like our wrapping to our present right here. Okay, it's on the outside. So how do you get rid of a square root? We square both sides. Then we are going to add 3 to both sides. So I get x minus 5 squared plus 3 equals 2y. Then we divide by 2. So when I rewrite this, I'm going to do this in inverse notation. So f to the -1 of x equals x minus 5 squared plus 3 all over 2. Alright, here. So find the inverse when x is less than or equal to 3. So here's the biggest thing is, guys, this is a parabola just like our graph on the first page. But we know that this inverse is not a function. So we're going to restrict the domain to less than 3. So let's solve. Let's change our x and our y. So we get x equals y squared minus 6y plus 13. Alright, so we have a little bit of a dilemma here because we have two y's. So actually, my hint to you is we are going to complete the square. We did this last year. Okay, so I have x. I'm going to move the 3 to this side, so minus 3 equals y squared minus 6y. What we're going to do is add something to this side. Well, whatever we add to this side, we also have to add to this side. What are we adding? We take our b value, divide it by 2, and square it. So we are adding, let's see, 6 divided by 2 is 3, 3 squared is 9. So what happens here is we're going to add 9. I get x plus 5 Oh, I just realized I made a mistake, guys. Sorry, this should be 13, right? This should be 13. There we go. Sometimes I make mistakes too, right? So negative 13 plus 9 is negative 4. There we go. Equals. Now, when we have this here, we're going to make a perfect square. If you remember correctly, we have y, and then what we do is this inside. So negative 6 divided by 2 is negative 3. And we can see if we were to FOIL or multiply this out, this is what we would get. Now we have 1y, so this is awesome. So how do you get rid of a square? We take the square root. Now when we take the square root, we get plus or minus. So I'm going to keep going with this because how do we get rid of the 3? We add it to both sides. So I'm going to put that on front right now. But since we are restricting our domain to less than 3 are negative numbers. I mean, I get it. 2 is not a negative number. But when it comes to positive, negative, so when we have less than, it means we're going to take the negative one. If it were greater than, we would take the positive. So our final answer is f to the negative 1 of x equals 3 minus square root of x minus 4. Alright, one more. Find the inverse f of x equals 4x plus 3 over 3x minus 1. As you can see, guys, there's two x's. So when we replace or switch x and y, we end up getting two y's in there. So we have an issue with two y's. But let's start with our other issue that we don't like. Usually many of you will say we have a fraction, so let's get rid of it. So we're going to multiply both sides by the denominator. Okay. Now your next move is you want to distribute that out. So we have 3y x minus x equals 4y plus 3. Now this is a new idea for most of you, and if you're going into a higher level math, you'll be doing this all the time, so pay attention. Because we have two y's, we want to do something where we can factor out to have one y. To do that, we need all the y's on one side and everything else with a y on the other. So this 3yx stays. We're going to move this 4y over. We move it by subtraction. And then we need to move this x from the left side to the right. This is subtraction, so we are going to add it to the other side. And that 3 stays on that right side. As you can see now, I have all my y's on one side, my non-y's on the other. What do they have in common? They have a y. So I'm going to factor it out. And that helps towards our problem because now we're down to 1y. We just need to get it by itself. So we are going to divide each side by 3x minus 4. And of course we need to write this in inverse notation. So f to the negative 1 of x equals x plus 3 all over 3x minus 1. Keep in mind that we are not finding domains, so we don't have to worry about saying what doesn't work right now. Alright, make sure as you do your homework you can compare back to these examples of what steps to do.